Uniform circular motion. Motion, obviously we're looking at something that is moving. Circular, surprisingly, is a circle. What is the key thing about a circle? It has a radius, right? So it has a constant radius. What do we mean, though, by uniform? So we've talked about something with a constant velocity, but velocity, as was said before, has a magnitude and a direction. So is the magnitude and the direction the same for an object that is moving around in a circle? No. We have an object going around in a circle. Let's say I look at this point here, it is going to be traveling that way with some velocity. We saw that when I released the projectile before, it traveled off in the direction that it was spinning, right? So what is constant in this situation? It's not its velocity, but its tangential velocity. What do I mean by that? Uniform tangential velocity would mean that its velocity to the tangent is always going to be the same. So that means I would, let's say, copy this, duplicate it, and then be able to rotate it and put it there. I would then be able to duplicate it again and move it there. I would be able to duplicate it, put it there. All of their tangential velocities are going to be the same. What is changing, though, is the direction, right? So that's what we mean by its tangential velocity is going to be the same. It's pointing with the same velocity tangentially from every point on the circle. But if its tangential velocity is going to be the same, it's going to have the same magnitude of velocity. If it has the same magnitude of velocity, it has the same speed. So our speed is equal to distance over time. What is the distance this object is traveling? The circumference of the circle, right? So it travels around in a circle, so therefore it's going to travel 2 pi r. What's the time that it's going to travel? Well, that depends on how much of the circle it travels, right? So if we say it's going to complete one complete revolution, we say that it completes its period. T is the period, and this is the time taken for one complete cycle. So if it takes, let's say, 5 seconds to complete one revolution, it would have a period of 5 seconds. Other way of looking at a complete cycle or a number of revolutions per second would be frequency. So frequency, which we give the symbol F, is how many complete cycles are completed per second. Our frequency is equal to 1 over t, so 1 over our period. Our units per second, we actually have a special term for this, mainly because instead of it just saying per second, we want to know its number of complete cycles per second. We use the unit of hertz. We now have this idea of frequency, period, distance, and time. However, as we've alluded to, we have a non-constant velocity. How is the velocity changing as the object moves around the circle? It's changing its direction. Which way is it changing its direction towards? In towards the circle. So the acceleration for an object traveling in uniform circular motion must make its velocity start turning back towards the center. So our acceleration is towards the center. Is it the only acceleration that's going to be involved? We could have other forces involved. We could possibly have an object traveling around on a circle on a road, in which case we would have normal forces. We could have frictional forces. We could have a whole range of other forces included. This means that for an object traveling in uniform circular motion, the net acceleration is towards the center. If the net acceleration is towards the center and I have a little rubber bung that's flying around, it means that the sum of the forces is going to point towards the center. So the sum of the forces, the net value is going to point towards the center. For an object that is traveling in uniform circular motion, the sum of the forces is going to be equal to mv squared divided by r. If we think about Newton's second law, which is mass times acceleration, That means that our acceleration of an object that is traveling around in uniform circular motion is going to be equal to its velocity squared divided by the radius. Any questions for me? If there are no questions for me, then there are questions for you.